The second biomolecule that we want to talk about today are the lipids. These are fats and oils. So I want you to take just a second and try to think of something that you could eat in your diet that would be considered a lipid that would have fat in it. Okay, hopefully you came up with something like this. Any type of oil, your cooking oil, there's peanut oils and olive oils and coconut oils. Anything that comes from an animal, so butter, that thing that makes all food delicious. Mayonnaise. Then there are also some plant lipids, such as soybeans and peanuts. Lipids are considered the concentrated energy molecule because they have lots and lots and lots of energy in them, way more than a carbohydrate molecule would have. The problem is it's harder for our body to get the energy out of the lipid. So lipids are kind of like an emergency backup plan for our body. So if you don't eat enough carbs to fuel your body will go to its emergency backup stores, the lipids, your fat, and then it will begin to get the energy from your fat. That's why most diets tell you to limit the amount of carbs in your diet so it forces your body to go into your fat stores and use the energy from there. An important idea behind a lipid is that it is not soluble in water. That means it doesn't dissolve in water. If you've ever cooked bacon, you know all that bacon grease that comes out? That's lipid, that's a fat. And if you put that frying pan in the sink, you notice that all that fat just floats on the surface in little bubbles, and that's because fat doesn't dissolve. That's really important to help our bodies store fat, and that's one of the reasons why it's so difficult for our bodies to break down fat to get the energy out. Lipids and carbohydrates we're doing on the same day because they have a lot of stuff in common. One, they both have to deal with energy. Carbohydrates, fast energy, lipids, long-term storage of energy. But they're also made out of the exact same atoms. So lipids are made out of carbon, hydrogen, and oxygen, just like carbohydrates. The difference, though, is the shape that these elements come together. Remember that in carbohydrates, they come together in the form of sugar rings. But in lipids, they're going to come together in a different way. Lipids are going to have two building blocks. They're going to have a head and then 1, 2, or 3 tails per head. The head is known as a glycerol head, and the tails are known as fatty acid tails. On the side here is a picture of an example of a lipid. Notice the blue circle, that represents the head, and then this one has 2 yellow tails. Those tails are just long chains of carbon and hydrogen. And that's the reason why lipids have so much more energy than carbohydrates, because they have a lot of carbon and hydrogen bonds. More carbon and hydrogen bonds equal more energy. How do we measure energy? In calories. So when you read the package of something that you're eating and it tells you how many calories it has, it's basically letting you know how many carbon and hydrogen bonds there are. So more carbon and hydrogen bonds equals more calories or more energy. And fats, lipids, have lots and lots of carbon-hydrogen bonds in those tails. And we'll see another image shortly. So, lipids are made out of a glycerol head and fatty acid tails. And what is their job? Well, their main job is that long-term storage of energy, and it's very concentrated energy. One lipid molecule has twice as much energy as a carbohydrate molecule because of those carbon-hydrogen bonds. So that's its main energy, or that's its main job, is to be this backup emergency energy storage. But it also has some secondary functions. It acts as the cell membrane. So this is a part of your cells that is sort of like the skin of the cell. And we're going to learn more about this soon, but just know that that's what we need lipids for, is to make the outside of all of our cells. It's also used as a cushion. It's kind of like an airbag for your organs. So every one of your organs has a little layer of fat around it to protect it. Without this layer of fat, your organs would become damaged by bumping into one another and by bumping into your bones, and it could actually damage and destroy your organs. This is what happens to people who are anorexic and their body fat content gets so low that they don't have enough fat cushioning their organs, and their organs start to shut down. So some body fat is a good thing. You need some. It also insulates our body. Think of whale blubber. Whales can swim in the Arctic Ocean and they don't get cold because they have lots of fat to insulate. Our fat insulates not only our organs, which is also cushioning, but we also have a very thin layer of fat around all of our muscles. And it insulates our muscles and keeps them warm. Because for our muscles to function appropriately, they need to maintain a certain temperature. So this is again getting us back to that idea of homeostasis that we talked about earlier. So now our bodies don't only need to maintain homeostasis in pH level, a specific pH level to protect our organs and our blood, but we also need to maintain a specific body temperature. So we need homeostasis in body temperature as well. Okay, what are some examples of lipids? Your fats. So any type of animal fat, the fat that comes on steaks and that are in hamburgers and bacon, those are lipids. Also oils, so all of your cooking oils that you have, canola oil, peanut oil, olive oil, those are all examples of lipids. Okay? Waxes, a really gross example, the earwax that you get. Earwax is a lipid that your body is producing. And fun fact, earwax is actually your ear's way of sweating because ears don't have sweat glands, so they produce wax instead. That's why you have more earwax in the summertime than in the wintertime. Steroids and hormones are also examples of lipids. For two hormone examples are testosterone in boys and estrogen in females. Those are both actually lipids that our body needs. Here's another example of what a lipid might look like. Remember, that is an important skill for you to have. You need to be able to look at a picture and say, oh, I noticed that this has heads and tails, so this must be a lipid. Notice this one, we have one head, which is represented in the gray area for you, and then the tails are represented in yellow. This example has 3 tails. Take a look at those tails. They are just long chains of carbons and hydrogens, carbons and hydrogens. Okay, that's where all that energy is stored in those carbon-hydrogen bonds. There are 2 groups of fats that you need to know about. The first one is called a saturated fat. Notice in the image with the head and the tail is represented in red and the tail is black and gray. With a saturated fat, saturated means it has as much as it can handle. It can't hold any more. So when it comes to fats, saturated means hydrogens. Okay? A saturated fat, the tails have as many hydrogens as it can hold. There's no place for any more hydrogens to go. This is going to make saturated fat molecules very rigid and unbendable because that tail is full of hydrogen, so there's no place for it to bend. Your saturated fats are going to be your animal fats that you get from bacon and butter and mayonnaise. It's going to be solid at room temperature. The reason why it's solid at room temperature is because it's so stiff and unmovable. So those molecules are going to stack together really tight and really neat, and that's why it's going to form a solid. These you want to limit in your diet because it's very difficult for your body to break it down and get it out of your body. And what can happen is that these can build up in your arteries and cause plaque buildup and lead to heart disease. The other fat is known as unsaturated. Unsaturated means that it is not saturated. And this is going to refer again to those tails and those hydrogens. Okay, if you look at the picture here at the bottom, notice that the molecule is bent. Okay, again, the head is in red, and it only has one tail, and that's represented by the gray and black. It has a bend in it. That's because there's an empty spot where a hydrogen could fit. So it is not saturated with hydrogens. It has some space left. Okay, this is going to cause it to be flexible, and it can bend. This is going to result in it being a liquid at room temperature, because now, since they're bent and they're flexible, they can't stack together to form that nice solid. So these are going to be healthier for you, and these are going to include your vegetable fats and your fish fats, so such as peanut oil, the oil that comes from peanuts. And it's easier for your body to eliminate these from you, so these are a healthier choice in your diet. You don't need to limit these. You need to increase these over the saturated fats.